Chapter 4, Number 13. One strategy in a snowball fight is to throw a snowball at a high angle over level ground. While your opponent is watching the first one, a second snowball is thrown at a low angle, timed to arrive before or at the same time as the first one. Assume both snowballs are thrown with a speed of 25 meters per second. The first one is thrown at an angle of 70.0 degrees with respect to the horizontal. A. At what angle should the second snowball be thrown to arrive at the same point as the first? B. How many seconds later should the second snowball be thrown after the first one to arrive at the same time? Part 1. What we're given is information for snowball A and B. Snowball A is traveling at 25 meters per second at an angle of 70 degrees, and snowball B is traveling at 25 meters per second at theta B, which we need to find. Once again, Part A wants us to find theta B, the angle at which snowball B was thrown, and Part B wants us to find the time difference, which is the time it took for A to go from start to finish minus the time it took from B to go from start to finish. To find theta B, we first need to find the time it took for this first snowball to go from start to finish. We're going to be using this equation, y final equals y initial plus vy initial times time A plus 1/2 g time A squared. Y final and y initial are the initial and ending elevations of the snowball. Vy initial is the initial velocity of snowball A in the y direction. Ta is the time, and g is the acceleration, gravity. Once again, Ta is the time A, which we need to find. Here I've drawn a makeshift representation of what's happening. The first snowball, snowball A, is traveling at 25 meters on the upper curve at 70 degrees. Snowball B is traveling on the dotted curve, the red curve, at 25 meters per second at theta B. Now you can plug in your values. Y final and y initial are both going to equal 0 because it starts at 0 elevation and ends at 0 elevation. G is going to equal 9.80. Vy initial is going to equal V sine theta. If we plug in values for V sine theta, we find that Vy initial equals 25 sine 70. Plug in that value and then solve for Ta. Plug those values into your calculator and simplify with Ta on the left side. If you do it correctly, you should find that Ta equals 4.79 seconds. Now that we have Ta, step 2 is to find the distance d that both snowballs will travel. We are now given that Ta equals 4.79 seconds, theta A equals 70 degrees, and the velocity of both of the snowballs equals 25 meters per second. We're going to be using these two new equations. The first one, E2, is delta x equals Vx initial times Ta. The next one, E3, is similar to the one for Vy initial. Vx initial equals velocity cosine theta. Now plug in all your givens. Plug in 25 for V and 70 for theta. Plug in 4.79 for Ta and solve. When you plug this equation into your calculator, you should find that delta x equals 41 meters. Step 3 is now to solve for time B in terms of theta B. We'll be using similar equations to steps 1 and 2, except in case of E1, Ta is changed to Tb. In the case of Vy initial, theta A is changed to theta B. Now plug all the values you have into the equation. You should still have two variables. Now solve for time B in terms of theta B. Now use the equation delta x equals Vx initial times time B. Plug in the value time B equals 5.10 sine theta B. Plug in velocity times cosine theta B from steps 1 and 2 in for velocity x initial. Put 41 as delta x, and now solve for theta B on one side. Simplify the equation and put sine theta B and cosine theta B on one side. Some of you may realize that we can now use the double angle formula for math analysis honors. This formula is sine 2 theta B equals 2 sine theta B cosine theta B. Bring your equation from above down and you'll see that you'll be able to do some substitution. On your double angle formula, divide sine 2 theta by 1/2. And now replace sine theta B cosine theta B with 0.322. Simplify and get sine 2 theta equals 0.644. Now we can solve for theta b. Make 2 theta b x and make sine of x equal to 0.644. Take the second function of 0.644 and make it equal to x. If you plug this into your calculator, you should get that x equals 40 degrees. X equals 2 theta b, therefore 2 theta b equals 40 degrees. If you solve during simple algebra, you find that theta b equals 20 degrees. And that's your answer for A. Part B is somewhat simpler. We're given that time b is equal to 5.10 sine theta b, and theta b equals 20 degrees. Time A equals 4.79 seconds. Our answer is going to comprise of time A minus time B. Therefore, all we need to do is plug in theta b. When you've plugged in theta b and plugged it into your calculator, you should find that time b equals 1.75 seconds. Plug these two values into TA minus TB. When you've plugged in 4.79 for TA minus 1.75 for TB, you get your final answer for part B of 3.05 seconds.